All right, so let me now just talk about one more important concept here called as synchronization. If you notice right now, I have no synchronization. So before we even move and talk about talk about or implementing synchronization, we need to understand what that exactly is. What is the use of implementing synchronization in your code? See, the idea is when you run a Java code, it just runs without waiting for anything. And that's what we don't want when it comes to the Selenium, because we need to match the speed of the code with the speed of the application. So let's say you clicked on something and the page is taking its own sweet time to navigate to the from one page to another page. And while that is happening inside the application, your code, your Java code has to be notified that it should wait and only then perform the next operation on the subsequent pages. If you're not instructing your development code, if you're not sorry not development code if you're not instructing your code, your automation code, that you have to wait, it will go there, it will move to the next line, and it will try to execute itself. And since it will require an element to be clicked which is not yet appeared on the application, because the application is still navigating, the test case will become brittle. It might fail abruptly. Sometime it will pass, sometime it will fail. All those things will happen. So to avoid all those things, we need to implement the concept of synchronization. Now, synchronization is again a umbrella word for implementation. There is few default implementations available in Selenium, so you can make use of it. Those usually solves all the problem statements of synchronization. In case if you are not satisfied with the conditions provided with the Selenium jar library, you can also have the privilege to write your own synchronization methods. So that custom synchronization is what I'm not going to talk about that for now. We're only going to focus on the available synchronizations mechanisms available with Selenium, which as I said, will handle all the nearly 90-95% of scenarios for you. Okay, this is that synchronization library which we have here is quite elaborate and will be able to handle most of the things. So it's important that we learn that first. So first and foremost, let me just again let me do a new share, whiteboard share, and I will erase all that. Clear? Okay, now let me just draw a diagram perhaps. Okay, or rather than diagram, let me just write. So in Java or Java with Selenium, you have three types of ways by which you can halt the execution. So whole idea of synchronization is to halt the execution until something happens, right? Now there are multiple ways to do it. So when you say thread dot sleep, now this is very common. This is called as hard-coded wait. This is something when you say thread dot sleep and you say 10,000, this means that you are instructing your code that once it reaches this line, it will stop the execution. It will stop there for 10,000 milliseconds, that is 10 seconds. Okay, it takes parameter in milliseconds. If you want to halt it further, you will say 90. So it will wait for 90 seconds. Okay, this is not a good approach. Why? Because it will waste time. What if you're thinking that your page will get navigated in, let's say, 40 seconds, and your page is actually getting navigated in 20 seconds. So you're wasting 20 seconds more. Your automation code is wasting 20 seconds. Okay. And how about you are saying you are automating an application, it turned that while automating, it was taking 60 seconds to load. So you have put there 60 seconds. And after that, performance of the application was improved and it used to take only, let's say, 5 seconds. So you are actually wasting 55 seconds. And how about if you are doing this in all your test cases, you have 1,000 test cases, and all those test cases says 55 seconds are getting wasted. You understand how big a significant impact it's going to be in your efficiency of the automation pack. Because these days what we need is the automation pack should give results faster. So execution within 3-4 hours is what is required. If your script is taking too much time, it's not good, or it's a bad design. So you should always avoid this. Only in very, very specific certain situations, very specific, very rare situations where you just can't use any of the fluent, custom based, any type of weights you're not able to implement, only then you should resort to using this. However, And even so, when you want to do it, you can still should not, your set.sleep should not be more than 5 seconds, I would say. Okay, so if you still want to do it, then you will not do more than 1 to 5 seconds. As I said, depends on your situation, but that is just a thumb rule that set.sleep should be completely avoided. Second concept here is, this is the first way of how you can put synchronization. It's a bad way, but still is a way, so I had to tell you. Second is, we have two kinds of waits. One is called as implicit, and then we have second called as explicit. Okay, and within explicit, there are usually people call it, there are two more called as WebDriverWait and fluent wait, which actually are one and the same thing. Fluent wait and explicit wait. Okay, so WebDriverWait is a class which is derived from fluent wait actually. So there are only two kind of waits here which is available in the Selenium. One is implicit, second is explicit. Within explicit, there are different mechanisms called as fluent wait or WebDriverWait by which you can implement it. Fluent wait and WebDriverWait are closely related. WebDriverWait is a special case of a fluent wait. That's how you can understand it. Okay, but for today, we are going to use WebDriverWait, which I said is giving you most of the features which you need. You can also use fluent wait to introduce few more conditions that we will talk about. But today, let's try to implement implicit as well as explicit. Okay, now what is implicit and what is explicit? These are English words. Implicit simply means something within. Explicit means from outside. Okay, when you say implicit, that means you are instructing driver and you're implicitly putting a wait there so that the driver or any operation which is happening within that driver, it will by default implicitly wait for a certain period of time before it throws an error. Okay, now I know this is a big line to consume, but I'll try to explain again. So when you say driver.find element and assume there is no implicit wait there, nothing is there, no kind of wait is implemented. So when you say driver.find element and inside that find element you have written buyer.id some locator, and God forbid that locator is not there. Assume the locator is not there. So what will happen? Driver.find element immediately try to locate that. It will not able to find it. It will immediately within millisecond it will say, I'm not able to find it, test failed. Okay, but that's what we don't want. Why? Because there is a possibility that the page is still navigating. The element has not yet appeared on the page. Okay, this is a high probability of it. So we are in this, by implementing implicit wait, we are instructing the driver to wait before you throw an exception. So now let's say we have implemented we have implemented implicit wait. So what will happen now when you write driver.find element and we are, let's say, instructed that let's wait for 30 seconds before you say I'm not able to find it. Okay, so what will happen in this case? Now since implicit wait is present there, when you do driver.find element and let's say element is not there, the driver.find element will wait for 30 seconds. And it will not actually wait for 30 seconds. It will actually wait unless the element is found or the timeout is reached. So if let's say element appeared in 10 seconds, it will not wait for 30 seconds. It will immediately do operation on that and that will move forward. So implicit that the amount of time which I'm telling you right now is a timeout. Okay, so let's first try to implement this implicit wait, which is relatively very easy to implement. And most of you, if you have done any Selenium work, you will be aware of it. So let me share my desktop again. I hope it's visible. What I do, as soon as I do this driver.new Chrome driver, I can actually write another statement called as driver dot manage dot timeouts. Timeouts dot implicit wait or implicitly wait, and inside this time you have to write the timeout. So you can give any unit to it. It could be seconds, milliseconds, microseconds, seconds. So what I'll do right now is to give it a 20. I prefer a millisecond. It gives you more flexibility. So I'll write time. So this will be your timeout. You need to mention what kind of value you are mentioning here. So this is another argument which you need to put, time unit dot, and here you can actually mention till when, what kind of value that is. So driver.manage or timeouts implicitly wait 2000. So now as soon as this is declared, the driver will have this instruction, and it will anywhere we are going to use this driver, the same time unit will be used. So as soon as the driver instance is open and you're not quitting it or something, it will have this instruction to implicitly wait for a specific period of time until unless the timeout is reached. It will not throw an error. It will not throw element not found exception unless the timeout is reached. And this is what I was talking about earlier, that this is only the timeout. It doesn't mean that it will wait for 20 seconds. It will not wait. If the element is found earlier, it will just start with the next instruction. It will start the operation and will not wait for 20 seconds. This is also called a dynamic wait. It will not wait for, so thread.sleep was a static wait. This is more of a dynamic wait. Now, in this dynamic wait category, as I was telling you in the whiteboard, that there are two ways. One is implicit wait, second is explicit wait. So maybe let me just show you that as well. Now the question is where you are going to implement that. So implicit wait is always implemented on a driver, right? Because as I said, implicit wait has to be present or being known to the primary object of the Selenium, is what is called as web driver or driver. Now explicit wait is actually, you mention when you want to specify a condition which is relevant to a specific element. Okay, for example, you want to click on a link, but before you do and click on that link, you need to ensure that the element is visible or the element is clickable. Or you need, let's say you want to wait till the alert pop-up is coming. Okay, or you want to wait for a specific condition. Let's say there is an element, when something happens, after some event happen, the attribute value of that element changes. Okay, now these kind of things happen. For example, you click on something and there is a button, it changes color, for example, right? So when you click on something, it becomes green. Then you click again on something, after some time it becomes red. So what is being changed there is, I think it's CSS value or it's some kind of attribute value. Now this is not always the case, and just for example I'm giving you, it depends how the element is implemented, of course. But the point is, if you want to wait for a specific condition for a specific element, in those circumstances you actually go and use explicit wait. Okay, so explicit wait is usually, if you want to learn or remember how this works, implicit wait is actually used on the driver level. Implicit wait is used at the driver level. Explicit wait is used at the element level. So I think you already are aware of it. There are two primary main important entities or objects in Selenium. One is web driver, second is web element. So implicit wait usually is applied on the driver level. Explicit wait is applied on the element level. If you want to validate, or if you want to wait for a specific condition for a specific element. So if you want to implement explicit wait, you of course have to go to the element level, and the element level in our case is managed inside page object model file, isn't it? So let's say this is our case, and this is where we would like to implement our explicit wait. So first of all, let's say why we need it, right? So in this case, let's say before I go and do a send keys text, before I go and let's say click on or send some value here, how about I would wait for it? So for example, there could be a possibility that as soon as you navigate to a browser and you navigate to a URL, this particular text box takes time to appear. Okay, so it might take 20 seconds, it might take 10 seconds, it might take 5 seconds. If you're not mentioning any specific value, it will actually, your test can still start failing at random, right? That's what we don't want. So again, I want to give a tolerance. So this synchronization concept is actually there to give your script some level of tolerance, so that your script, automation script, can tolerate the behavior of the application, right? So in this case, let's say I want to implement explicit wait for this element, because I want to wait till 60 seconds before you say element not found. Then you can say, okay, I'm not able to find the element, and you can fail the test, but not before 60 seconds. Let's say this is my scenario. This is what I need to implement. So what I'll do, in Selenium, we have a class called as WebDriverWait. So we have to create an object of it, new WebDriverWait. And in this, I need to pass 2 arguments. Okay, let me just show you one thing first. So as soon as I do this, I will be asked to import some objects. So I will import it, and then again it will say something, that is, I need to pass some arguments. And this is how basically in Java you know what exactly is you are missing. So let's say you're getting an error, you say, sir, error is coming. That's what I hear all the time on the groups and all which we have. So that's how you basically will realize or understand what's missing. Okay, so always click on these kind of buttons, these kind of bulbs, error messages, see what it is. So it's saying what you have written is not matching the constructor, or not matching the argument or constructor argument. So I will say, okay, I will select this one. So that means this requires a driver and it requires a timeout. Now I can write here 20, okay, or 20,000. Now how would I know whether it's a seconds or it's a milliseconds? Best way to do is to go inside the class. So once you click on this, it will take you to the source code of this library. And if you remember, I was telling you that WebDriverWait is an extension of fluent-wait. So both fluent-wait as well as WebDriverWait are related. WebDriverWait is a special case of fluent-wait. Okay, so that's why I am only right now implementing WebDriverWait. Fluent-wait will again implement, we'll learn what it is maybe later, but WebDriverWait will solve our purpose for today. And if you also see, this is the WebDriverWait which we are looking for, and this is WebDriver it is accepting, and it is taking timeout in seconds. Right? That's how I would know whether it would require a milliseconds or a second. And it's very good documentation about it. You can actually read what's happening. Okay, this will tell you a lot of things, condition, until, immediately, forget, all the many things it will tell you. You can actually go and read these documentations for you to read it, to understand how it works. Let me go back, right? So now my declaration is correct. Then I will write wait dot until. Okay, when I do until, it will, inside this bracket, I need to put some expected conditions, isn't it? Because that is the whole and sole purpose of implementing this wait. That is, I would like to wait for my automation test for a specific condition to meet for that specific element. For that specific element, the specific element is the search text box, right? So inside this, I need to write a class called as expected conditions dot. Now here comes a list. Now that is what I was talking about when I said it is very elaborate. So this list has everything, almost everything which you might need to write your expected conditions. If you want to wait for alert is present, if you want to wait for attribute contains, attribute to be, element to be clickable, maybe this is what we're going to use. Then frames, invisibility, visibility, okay, presence of element, staleness of element, text matches, text to be, for example, you want to wait for a specific condition, that is text. If this text is coming, then till that point wait and then move forward. Okay, so these kind of things, you can use text to be, title, visibility, invisibility, it's URL. You can also wait for URL to match, URL contains. So when you navigate, you have to wait for that specific URL is navigated to or not, if that URL contains a specific keyword which you require. Right, so all those conditions, expected condition, are present here, and you can very well use it. Right now, for me, what is relevant is I can choose to select element to be clickable. Okay, this I can also could have written visibility, invisibility. Right now I'm choosing element to be clickable. That is, if there is an element and it is a link and it is clickable, I would assume that the page is loaded. Okay, or page is there, or sorry, that element is there. All right. So if I say element to be clickable, let me select this, and inside, by the way, one more thing I would like to mention here, because I don't want you to be confused. So when I say element to be clickable, it has different overloaded methods, right? So in Java, you must have aware about overloading. Of course, we're going to understand from OOPS concept perspective later. But these are overloaded method. That means the same name is used, but different argument types. So element to be clickable, that means it accepts a web element. This element to be clickable, this accepts by locator. So we actually need by because we have defined our locator in a by format. So we are going to select by, and inside here, we are going to write this. Okay. I think we are missing a bracket, right? So now your explicit wait is implemented, as simple as that. So what will happen now? As soon as you run this, it will, when it reaches this set search text box, it will wait for that element to appear. If it appeared, if it is taking some time to appear, it will wait for 60 seconds for it. If it comes before 60 seconds, it will move forward and will do this operation. If it is not appearing even after 60 seconds, it will fail the test case here and exactly at this point, line number 22, and will say it is not able to find the element. Element did not become clickable. It's not there. All right. Now there is one more last thing with it. That is, I'm kind of passing the locators twice. So one, I'm passing it here, and then I'm again trying to find it here. I don't want to do it. So there's good thing with WebDriverWait, that is this until, if you can hover on it, it returns a web element. Okay. So the idea is, if it is found, then the whole statement, this until statement, will actually return the web element for it. Okay. It will actually return the web element. So this line, you don't have to write completely. What you can do, you can remove this and you can write element dot send keys, because that find element is not required, because that already happened within this method. Okay, it already happened within this method and it is returning you the web element. Okay, you can read the description here. It's of course a bit high on Java side, but you can try to understand what's happening. Okay, let me go back. So now this becomes your test case. In this test case, you are applied the WebDriverWait for this. This is actually was not required to be in this, for just for demonstration purpose I've done it. However, it's always a good practice in a good framework that you, before you do an operation on any element, you actually wait for it. You actually wait for that element to appear and then you do the operation. Now, if you use, when you use explicit wait and implicit wait both, it has actually a good practice to do that. So I am using, if you notice, I'm using driver.manage, that is implicit wait, and as well as I'm using explicit wait. Now the idea should be, the thumb rule is, implicit wait should always be used no matter what. So the moment you do a driver.new Chrome driver, you always should use implicit wait. Now explicit wait is something which you can choose to use if you need it. So it depends on the situation. Also, sometimes people believe that, and they develop a framework in such a way that is when you try to perform any operation, so send, please, or click operation or get operations on any of the element, you should wait for it. So that is usually a good practice to do. It gives, as I said, it gives a good tolerance. So I should actually go ahead and implement this WebDriverWait everywhere. Okay. And again, if I do that, it will be a boilerplate code, because I would be repeating the same steps again and again and again. And again, that is not good for the framework. So we, in the coming videos, in the coming sessions, we are going to organize, structure our code in a better way. And we are going to create a lot of reusable methods to manage these kind of things. So maybe just for a hint, we are not going to directly write send keys here, click here. We are going to create separate interaction libraries. And inside those interaction class, we are going to declare the send keys and click methods. And inside that, we are going to perform these wait operations. And from these from these page object files, we are going to call those methods. It might ring some bell or it could be completely confusing. Don't worry. Right now, we are focusing on this. That is for something for later. Now, one last thing with this video is about maximizing the window. So if you notice, if something, when I do something, sorry, when I run it, it actually opens and it doesn't maximize it. So it's good practice to run your test case when your browser is maximized. So again, for that, the control is driver dot windows, not windows, dot manage dot window dot maximize. So when you do this, it will maximize the window. It will do the operation on it. Inside this driver, there are many methods, by the way. You can actually go through it. I might not be covering all, but it can do many things. It can do delete cookies, add cookies, you know, all the important things you can try with this. It can switch windows, so that is another topic. Sorry. So for example, if you are clicking on a link and that link is being opened in a separate tab, that tab is considered to be a window, and if you want to switch to that window, you will do it from here. Similarly, frames has to be switched. That again is something which we'll do. We'll have a look later. Right now, I'm just remove this. Now, one last thing which is present here, that is, if I run it, let me run it first. So if I go and run it now, so this time it maximized, it entered, and it is passed. My test case is pass completely. Now, last thing is, if you notice, when my test case gets over, the browser is still open. So this will lead to a problem, because if you run every time I run the browser, my test case or my automation framework should have this capability to close the browser after test case is over. To implement that, I will tell you another thing, that is, and now this is something which is related to Cucumber. So let me introduce that. So what I'll do, I will create a special method, and I will give it a name as public void, call it cleanup, and I will, at the top of it, I will write after, right? So if I hover on this after, I will get 2-3 things. I'll get a JUnit after, I'll get a Cucumber after. In this case, since I'm using Cucumber, I need to select Cucumber after. Okay. How this works, as soon as you run a test case, the test case which is actually being executed is this, which is available in the feature file. So when you run this, once this test case is over, this method which I declared here gets automatically executed. So whatever is present inside this after method will get executed. So what I should be writing here, I should be writing a command to close my browser. So driver dot close driver dot quit. There are basically 2 commands available for closing the driver. So one driver dot close, driver dot quit. Now there is a slight difference between these two. Driver, let's say you have a browser, and inside that browser you have 2 tabs open, right? Tab 1, tab 2. So driver.close actually closes only one tab. However, driver.quit closes everything, right? And in our case, since there is only one tab and we want to close everything, we are going to use driver.quit. Okay. So now if I go and run this for the last time, run as JUnit test, maximize, and del entered, validated, and it's closed. So browser also is this time is closed, and this is the instruction to do it. So I think that is what I wanted to talk about in this video. So that is synchronization, as well as some maximize mechanism, perhaps the how to quit, and another concept of Cucumber, that is after method. This actually in Cucumber is called as hooks, and we're going to make use of it later, but for now only after is what I'm using. So there is another thing called as before, but that we'll do understand later. So thanks for today.